Episode 30 of the World of FPGA Podcast. It was time for a little trip again. I went to Munich to the 3-day FPGA Conference of PLC2 and the Vogel Verlag. Welcome to the World of FPGA Podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. After I'm getting my voice back, because I had a little cold after the trip, I would like to report today about the FPGA Conference 2025 in Munich. The FPGA Conference is one of the biggest events in Europe. First, here are some facts. The conference was a 3-day event. We have there more than 430 participants. There were 128 lecturers, 110 speakers, 39 exhibitors, and it was a complete international conference. So more than around about 50% of the participants does not came directly from Germany. And this was a triple anniversary year this time. So we have 40 years FPGA, we have 30 years PLC2, and we have 10 years FPGA conference. And there was a very, very nice event at the first day of the conference in the evening. So that is the facts, and now I would like to talk about the talks I have visited. In some there were 20 talks I have visited, so I will go straight through the list here. The first was Welcome to the Post-European Cyber Resilience Act era. Speaker was Marco Höfle from AFNet, and he talks about, the CRA from the European Union, and it was a little bit an introduction what should happen now for the next development of devices. So we have as primary target embedded devices. It is at least necessary that you have a secure boot and a measure boot that could help that your product would comply to the CRA. You have also to start with the cybersecurity at the beginning, so security by design. And one important thing was you have the timeline. So everything is starting as mandatory on the 11th of December 2027. So in 2.5 years, every product must comply to the CRA. Well, and for embedded systems, it would be a good idea to have a TPM device for passwordless decryption of the system. The next lecture, also about CRA, was FPGAs and the Cyber Resilience Act. And it was a talk from Roger May from AMD. And more or less it was the same, but some points I want to add to the last talk. We have FPGAs and microcontrollers with security-related functions, and these devices are not in the default class. These devices will go into the important class 1, so you have some more things to do. And the CRA also covers devices like ADCs, DACs, RAM, and so on. So everything what is indirectly connected, or what could be indirectly connected to a network. Okay, that would go into a default category, but if you have some devices on the intranet and on your company or in your production, they could be indirectly connected to the internet over maybe some bugger's router, and so your device should be safe. And the CRA risk assessment is fundamental for your work. So the next step you should now do is first create an inventory of your digital elements Then you have to classify the products. And third, you have to do a gap analysis. On the fourth, you have to start looking at a risk analysis. And at the last point, you have to work together with your supplier. The next talk is Cyber Resilience Act, Planning Your Security Future. It was from Martin Kellerman and Brian Colgan from Microchip Technology. And here, all the things from the talks above are the same, but to add some additional points, the CRA is in all phases of the product life cycle, and also 5 years after the end of your product life. So you have to think about an appropriate phase-out process in your company. And it covers hardware and software. What is not covered, and this is, I guess, also one important thing what has been chosen, is that non-commercial projects, including open source and cloud software, is not covered by the CRA. So if you're developing any software tools who are not commercial, you didn't have to comply to the CRA. And if you have a complete system with different firmwares and different controllers or FPGAs and so on, it would be a good idea to have a secure board controller that can do all the security things and firmware checks and so on for you. So it would be a good idea to have this kind of controller if you have more than one device, so that you not have to secure all your single devices, but to have one device you have to secure. Yeah, the next was making simple FPGA test benches utilizing important quality measurements. It was a talk from Espen Tallaksen from M-Logic from Norway, and he talks about UVVM and all the things behind this. I think I will make an extra episode about UVVM in one of the next episodes, so I have a long list I want to talk about. The next talk was a Cuckoo hash-based CAM architecture for FPGA and ASIC implementation. Speaker was Clinith, I can't speak the name, from Cast Incorporated. And it was about, on one hand, on CAM, so a content accessible memory, and on the other hand, the Cuckoo hash-based algorithm based on 2 hashes and 2 hash tables. And it was an implementation, how you can use it, for example, for TCP/IP sessions and sockets. And it was all about the Cuckoo hashing. You can read it in I guess it's also in Wikipedia. The next thing is elevate your design security and power efficiency with AMD Spartan UltraScale Plus FPGAs from Carsten Todd. And it was about, the new device from AMD, the Spartan UltraScale Plus. So the Spartan comes back again, and I'm just waiting for a new project I can put the Spartan into. And this was just a talk about the features and other things about the Spartan UltraScale. Interesting is, if you want to do something with this device, the first engineering samples will come at the second half of 2025. So, maybe the next now or before the end of 2025. Well, let's wait for it. And another interesting thing is you have an integrated root of trust and the post-quantum encryption what would be a good idea for things like CRA if you want to implement it. The next talk was faster change of probe signals using the Vivado Logic Analyzer. That was a talk from Nikolai Krasin from the PLC2 company. It was about the logic analyzer, the ELA core you can use in your design. And often it is so that if you change any wire on the ELA, you have to resynthesize, you have to re-implement your design. It costs a lot of time. Sometimes it costs an hour or a couple of hours for big designs. But there's another way if you just want to test some signals. You can use the so-called EcoFlow. Eco is engineering change order. And with this EcoFlow, you can now change the connection from the ELA core, from the logic analyzer core, to other nets inside your design. And it's important to know that you can change a lot of things with this EcoFlow, but in this case, you will now disconnect from one net and connect to another net, and the Vivado software will now reroute only the changed connections and not the whole design. So with this kind of change, it is possible to save a lot of time when you're changing, if you want to just to debug some of the signals. And you're just working not on the original project, you're working on a design checkpoint. So it's only temporarily thing that you can change the connection from the ELA core to another net. Next was warning, your FPGA and SoC FPGAs are under attack. It was from Oren Hollander from Hands-On Training, and he shows a lot of vulnerabilities of FPGAs. There were different kinds of attacks shown, and there was one thing what was quite important, interesting for me. So if you build your systems in another company, for example, in a electrical manufacturing service or an EMS service, then you will need to let them program your device. And this is an unprotected environment that's not under your control, and you have to be sure that this environment where you let program your devices will not infiltrate your system, so that you haven't any botnet support then after the system is coming from the EMS company to you or to your customer. Next was functional safety for hardware and software. It was with, again, Martin Kellerman from Microchip Technology and from Nikolai Velyanov from Green Hills Software. And they just talk a little bit about safety from standards, functional safety, and the important things at functional safety is that things will fail. They need to fail safe. That's important. If things fail, then it must fail safe. And, well, it should not happen too often. And functional safety is there to avoid injury and death and serious damage. Okay, and then they talked a lot about functional safety inside different microcontrollers, especially from Microchip, of course, because Martin is from Microchip. The next one was security regulations, FPGA-based systems, how to make your system secure. It was from Matthias Lai and Harald Friedrich from Newtech GmbH, and it's again a topic on CRA. They talked about that FPGA products and their IP cores are both digital products. So also IP cores. If you're an IP core company and you want to sell your cores, well, you have to take a look on the CRA. If you are, it is a point that it's important for you. And again, it was a hint just to follow the IEC 62443. Just to get an idea what to do. So it's some bullet points here are organization enablings. It's a kind of process development inside your company. It's important that you have a security process. It's important to have a security product development and security incident management. Well, this is important from September next year. So September 2026, you need an incident management. You need a security update management. It's important to have a threat analysis and risk assessment, public key infrastructure. You have to make your decisions based on risks analysis. Threat analysis and risk assessment is important. You have to identify, assess, and mitigate cybersecurity risks. And common elements are identify assets and entry points. So you have to minimize the attack surface of your system. So not open every port and everything. So just only open what you need for the functionality of your system. Yeah, some practical tips were security should be integrated early. You should use the threat modeling through the whole life cycle of the system. Again, life cycle doesn't end with end of selling, it's end 5 years later. And you should align with safety where it is applicable and always have a maintain updatability. Well, and documentation, everything, everywhere. So it's just needed for your compliance. And the last point was, and that's also very important, every product must be updatable. So the it must be updatable. Okay. It's on you. If you can update it over the air, it's fine. But if it's not possible, you have to send a service technician to do the updates. But it must be possible to do an update. The next was verify the bits that fly, a demonstration of bitstream to HDL equivalence checking. That was from Jonathan Graf Research Corporation, and they developed a tool which compares the generated bitstream with the HDL sources, so with the netlist, for example. That there will not be any changes while you are doing the implementation, the place and routing and the bitstream generation. That's for, I guess, more for high security things, but well, it was interesting. Yeah. The next was a fine-grained multi-threading RISC-V for FPGA systems. The speaker was Professor Dr. Bernhard Lang from the University of Osnabrück, and his idea was, okay, we want to have an FPGA which has an RISC-V processor included, so resources and FPGA support was important. But while he's studying this kind of processor, he was thinking about, well, when I have just only one task, the task is going through the processor, and the most elements in the pipeline will be waiting for the next task. So he just created a processor with a special additional feature with multi-threading. So you can start, and he has demonstrated it, you can start inside your, for example, C program, different tasks, and the task will go directly through the microprocessor, so through the RISC-V, and it's not that your real-time system or that you have a scheduler. The processor was able to do this on its own because it was a feature inside the hardware. That was quite interesting and impressive. Also, the demo was impressive. The funniest thing was that he completely started the whole development system and the debugging tool chain and so on from a USB stick on the presentation laptop. He doesn't carry his own laptop there. He just carried his development board, connected this via USB, and then started everything from his stick. That was an interesting situation. Next thing was why vUnit. It was a talk from Michael Pakula from Aldec. It was all about unit level verification, which supports VHDL, Verilog, and so on. Well, that was one talk I left earlier. It wasn't a little bit confusing. But, well, okay, vUnit is also one kind of where you can check can you validate your code. The next is managing and versionizing gateway source code on Git with Hog. I guess this was Hog. Speaker was Davide Ziri from Max Planck Institute for Physics. And Hog is a toolset with can be used with different development tools, so just for example with the Vivado toolchain. And Hog works together with JIT, and it was again a little chaotic presentation, but it was very interesting that you can have a toolchain which helps you to put your, for example, from Vivado, your design without any problems into Git and get it back from Git later on. The next was the based management controller for FPGA and SoC boards, supervision and faster bring up. This was a talk from Patrick Lehmann and Navid Jalali from PLC2. And they just talk about their own hardware development. They had a big FPGA hardware block, a big rack, and this need a lot of power. They have in some 3 power modes and 72 power rails, if I noted correctly. And they just wanted to have a system controller for supervision of overcurrent, temperature, fan, and so on. And they just showed the basic design ideas, how they created the design with a lot of I2C devices and multiplexers and GPIO expanders, and how they integrated it into the firmware of the base management controller, and gave some ideas how to handle with this. Then there was a talk from Cologne chip. It was gate-made FPGA qualification for radiation-tolerant applications. And it was directly from the CEO, from Dr. Michael Gude from Cologne chip. And, last time I talked with Glenn about this kind of FPGAs, and it was just interesting to see again with how this device is created. And they have a patented multi-die concept, which are the following. You have one basic FPGA chip, and you can cut off the wafer 1 chip, 2 chips, or 4 chips, or 9 chips, or 25 chips. So you're just cutting them. You're just cutting bigger chip out of the wafer, and between all the die there are, in any direction, if I have it correctly, more than 1,000 connections between them. So the routing software knows which device is it and knows, okay, between these 2 FPGA cores, I have the number of high-speed connection lines inside the silicon. So you didn't have to bond anything or something like that. So you can use it, and it's a very impressive and impressive design, and a good idea how to work with such high costs in creating an own chip. Well, it's MIPI compatible. It has 5 gigabit ZS IOs with 1.2 to 2.5 volts. It's tolerant for 3.3 volts, and they have just tested it. And interesting was it has an open source toolchain. It's using Yosys and NextPNR, and that's interesting because all the other vendors have their own tools, but here they are completely using an open source toolchain. Yeah, and the main topic of the talk was that they have done some tests about radiation effects, so like ionizing dose or single event effects and things like that, and it was quite stable. The FPGA was quite stable, and so they will have an gate-made FPGA in space at the end of 2025. So they are working together with the universities in Hamburg to send a board to the space. The next talk, also from Cologne chip, was Gate-made FPGAs, high-speed transceivers, ZERDES hands-on. Speaker was Patrick Urban from Cologne chip, and he just talked about the architecture, the tool chain, how to create a design with an ZERDES. In the datasheet, only 2.5 gigabit per second are noted, but the silicon is possible to do 5 gigabits per second. In the toolchain he used was IOSIS plus ABC. Then he has a JSON netlist. It goes into the next PNR, created the bit file, opened the open FPGA loader, and put the design into the FPGA board, which he carried with, and it just took seconds. It was impressive. And just give a detailed look into the gate-made ZERDES. It is, I would not say it's a copy of the AMD GTP, but it is very near to the design. It's not the same, but it's very near because this design is good known from a lot of FPGA engineers. And if you want to create a new design, it's often a good idea to base on existing knowledge. So they showed the 1000 base X implementation and an example, and there is this loopback example is also on GitHub, just to have a look on it. Well, you are welcome. Next talk was project-based and non-project-based scripting in Vivado. Speaker was Ernst Wehrlage from PLC2, and on the one hand you have the possibility to have a project-based design flow. In Vivado you have a project file with the end XPR and including different subfolders which have always the same name, the same ending. And the GUI just uses tickle-decay, tickle commands, not tickle-decay. It uses tickle commands, for example, for creation of the project, to adding sources and so on. And if you're interested how Vivado is doing it, you can look into the Vivado journal file. It's somewhere on your file system. Maybe sometimes it's under the user, sometimes under other directories. But you can find the journal file, and there you will see every single tickle command the GUI is starting to do things in the project. On the other hand, you have non-project based scripting design flows. You have no project files, you have no file sets, but the IDE, so Vivado, can be used on different stations, but you can use a lot of different additional programs. So you are more free in automation and so on. But it's not possible to mix both modes. You have to decide. Am I using the project-based mode or I'm using the non-project-based mode? Next was multi-run management using Vivado, also from Ernst Wehrlage from PLC2. If you are using the out of content, so it's in Vivado, there is a possibility. If you have IP cores, you can use the out of content synthesis. So all the single blocks will be synthesized, and if you're doing your design, you will save time, but they are ignoring eventually some constraint files. Additionally, you will get a lot of more constraint files because every IP will get its own constraint files like name, and at the end this is ooc.xdc. But the global synthesis configuration will not change any of the out-of-context modules. So if you want to optimize your synthesis, it's necessary that you have that you synthesize your whole design at once and not over the out-of-content functionality. The main topic was to use different or additional synthesis and implementation runs. So using different constraint sets for implementation or for synthesis, but it's important to know in project mode you can only implement, only the implementation can be changed with a new constraint set and not the synthesis. If you're using non-project mode, it is possible to change both. So you can have different runs with different constraint files, so different configurations of your implementation and of your synthesis. Last but not least, we came to the talk how to drive parallel high-speed circuits from an AMD FPGA. And the speaker was myself. It was my talk on the third day of the conference, and the room was completely full. That was amazing. It had made a lot of fun. I've got a good response to my talk, but I was a little too fast. So maybe I haven't enough slices, or I've talked too fast. I don't know exactly what it depends on, but I was too fast. But so all of my participants can get their coffee earlier. And the essence of my lecture was using the hardwire SerDes components, which are inside every single I/O pin in the logic blocks of an AMD 7 series FPGA. So you can, for example, take 32 of them in parallel to get the data in parallel out to a device, to a high-speed device, over 32 data lines. And internally, you will have 256 data lines because you have a SerDes. The SerDes is changing the parallel to serial data stream, and there you can have a factor of 8. So you have 32 times 8, that's 256. And the FPGA can handle this easily because you have enough resources, and it is quite slow in comparison to the outside world. If you want to get the slides, just send me a message and, for example, an email or maybe also on LinkedIn, and I can do this. Well, at the end, I need to left earlier my the conference because I have to get my train back to Berlin because of some changes in the at the Deutsche Bahn side. So if I leave later, I wouldn't have got on the same day back to Berlin. Well, this is why I've missed the talk of Professor Dr. Koch from the University of Heidelberg. His topic was partial configuration. Is it useful or just an academic toy? And it was always a very funny lecture from him. It was funny to listen him to his talks and to his stories. Well, but maybe next year, and that's a good a good reminder. Next year again, at the beginning of July, the next conference will happen in Munich, and the first blind ticket can be bought now. I think I will put a link into the show notes. Well, and I'm also thinking about the next talk at the next conference. What would be the next topic? But I guess I will have enough to speak about. So that's all for today. My voice is leaving again, so I will. And now I hope we can see us at the next conference and have some discussions there. All links and further information can be found at world-of-fpga.com/WFP030. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye, here next time, your David Kirchner.